So let's say we have the case where someone throws an object up, goes up, comes back down, strikes their hand again, and the whole thing takes 10 seconds. Okay? We can ask things like, how fast is it going when it comes back down? How fast did I have to throw it? How high did it go? And so on. And we can divide this up into three points. So we have when we initially threw it, we have at the very top, and we have when it comes back down to the person's hand. Now we draw a speed time plot, and again, we have time, we have speed. This is moving up, moving down. We have some initial speed, which I'll call V0, because after we release it, there's just gravity, so we have a straight line, and the slope of that line is -10 meters per second every single second. Now, this is at least true on the Earth. It would be a different constant on another planet. We have the 3 time points: when we threw it, when it reaches the top, and when it reaches their hand again. And we're told that this time, from here to here, is 10 seconds. Okay? So if that's the case, that means that time 1, 2 plus time 2, 3 should be equal to 10 seconds. And just from the diagram, we can tell that these should be equal. And so we have the time 1, 2 is equal to 5 seconds. Given that, and then just the equation of the line, we know that the speed at any given time is just the slope, -10 meters per second every second, times the time, plus the initial speed. Now, if the time happens to be time 1, 2, so this first part, the speed ends up being 0 at that time, which immediately implies now that if t12 is 5 seconds, that immediately implies that the initial speed had to be 50 meters per second. And if you do this by adding the 10 meters per second times time to both sides, this is a positive number. And so the initial speed has to be up in there. We can check that the speed at time essentially t12 plus t23, so at 10 seconds, should be -10 meters per second every second times 10 seconds plus this 50 meters per second. This is -100 meters per second plus 50 meters per second. This is equal to negative 50 meters per second. So it's essentially going down at the same rate that it was going up at the beginning. Now, how high does it go? Well, this height, okay, is the area under the curve here. And so that is 1/2, excuse me, 1/2 the base, and the base is 5 seconds, that's t12, times the height, which is 50 meters per second. And excuse me, and so this ends up being 25 meters. All right, so just from the geometry of the shape, we can figure out what the height is, and because that's the height really is the length that this thing moved through in this time. After 10 seconds, the height will be the area under the curve, but we have an equal positive area and an equal negative area, and that would be 0. So then the height would in fact be 0, meaning that it came back to where it came from. So this is a speed time plot of an object thrown in the air where you're given the total time, and again it's the same sort of picture.